Good morning, students. In the last lecture, we discussed about the practical determination of the end correction of the vibration in the air column when it is open at both ends and closed at one end. Today, we are going to discuss another very important topic, which is nothing but the vibration of string. So what is vibration of string and what we are going to do in this topic? So vibration of string means when a string is stretched between two rigid supports, when the string is stretched between two rigid support, and when we plug this string, then there is a formation of wave within the region within the two support, and the stationary waves are formed. Now there are so many modes of vibration of string, but we are going to study the first three mode of vibration of the string. Okay, so what is the vibration of string? Suppose this is a string which is stretched with a tension capital T and having the linear density M, that is mass per unit length. Okay, so this is a string having linear density M is equal to mass per unit length, and the tension due to this rigid support is equal to capital T. Now if if we plug if we plug this string, then there is a formation of wave within this rigid support, and when this wave reach this support and this support, it get reflected. Then the incident wave and reflected wave interfere with each other, and there is a formation of stationary waves. Now, the modes of vibration depend upon how we can plug the string. If it is plugged at one place at the center, there is a first mode of vibration, and so on. We can produce the second mode, third mode of vibration of the string. These waves are called, they are the transverse stationary waves because they are traveling, the particles are vibrating perpendicular to the direction of propagation of wave. And we know that when we are considering the transverse wave, the velocity of transverse wave is given by v is equal to under root T divided by M. What is T? T is the tension in the string, and this M is the linear density, that is mass per unit length. Not only mass, but this M denotes the mass per unit length. Okay, so now we are going to determine the expression for the fundamental frequency, first harmonic, second harmonic, as well as the overtones. Okay, in the first mode of vibration, second mode of vibration, and so on. So let's start the first mode of vibration. How the first mode of vibration formed? Suppose this is a string stretched between two rigid support, and we plug at this point, then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a stationary wave like this. Then there is a formation of a sta Now this is incident wave and this is reflected wave. So due to incident and reflected wave, the combination or the interference of these two waves, we get a stationary wave, and this is called as a loop. This is called as a loop. And also remember that when there is a formation of the stationary wave within the string, within the rigid supports, there is a formation of node at rigid support and antinode at the middle. So, in the first mode of vibration of a string, there are two nodes formed and one antinode is formed. So, this is the first mode of vibration. Let us consider the tension in the string is equal to capital T, and the small m is nothing but the linear density, that is mass per unit length. Okay, so this is the first mode of vibration. Now we know that आपल्याला हे माहिती आहे की दोन अँटीनोड मधलं अंतर किंवा दोन नोड मधलं अंतर हे किती असते, तर दोन नोड मधलं जे अंतर राहणार आहे ते अंतर राहते लॅम्बडा बाय 2. म्हणजे आपण असं म्हणू शकतो की या नोड मधलं आणि या नोड मधलं जे अंतर आहे ते अंतर आहे लॅम्बडा डिवाइडेड बाय 2. परंतु we are considering that the length of the string, हा जो स्ट्रिंग याच्या मधामध्ये आहे त्या स्ट्रिंगची जी लेंथ आहे ती लेंथ L. याचा अर्थ आपण असं म्हणू शकतो, from this we can conclude that this L must be equal to lambda by 2. This is the length of the string, and by the property of the stationary wave, the distance between two successive nodes is equal to lambda by 2. So we can write L is equal to lambda by 2, or we can write lambda is equal to twice L. Okay, so what is the velocity of this wave? What is the velocity? So we can write here V is equal to N lambda. What is N? N is the frequency of the wave, and this lambda is the wavelength of the stationary wave. Therefore, we can write here N is equal to V by lambda. But what is V? We already see that what is V is equal to? It is equal to under root T by M if it is a transverse wave. So, and what is lambda? Lambda is equal to twice L. So we can write here 1 upon twice L under root T by M. So this is the frequency of the first mode of vibration of a string. Okay, जेव्हा फर्स्ट मोड ऑफ व्हायब्रेशन आपण बघणार तेव्हा त्याची फ्रिक्वेन्सी आहे व्हायब्रेशनची, त्याला म्हणायचं आहे फंडामेंटल फ्रिक्वेन्सी. तर ही जी फ्रिक्वेन्सी या ठिकाणी आलेली आहे या फ्रिक्वेन्सीला तुम्ही नाव देऊ शकता फंडामेंटल frequency. And this fundamental frequency is equal to first harmonic. Okay, so the frequency of the first mode of vibration is called as the fundamental frequency, which is equal to N is equal to 1 upon twice L under root T by M, which is also called as the first harmonic. Now we are moving towards the second mode of vibration. What is second mode of vibration? Consider this is a string having length L. Okay. vibration of this string, there are the node formation at the repeat support, and at the middle there is a formation of antinode. So we can write here so this is node, this is antinode, this is node, this is antinode, and this is node. And we know that the distance between two successive nodes is equal to lambda by 2. Therefore, we can say that the distance between two successive nodes is equal to lambda by 2, and between these two successive nodes it is also equal to lambda by 2. Therefore, we can write the total distance between these nodes are equal to lambda. Lambda by 2 plus lambda by 2 is equal to lambda. So, here we can write this L is equal to lambda, but we are going to denote this as a lambda 1 because this is the second mode of vibration. Therefore, it vibrates with a different frequency as well as a different wavelength. So this is the wavelength lambda 1. Now we know that what is the velocity in this case? V is equal to n1 lambda 1, where n1 is the frequency of the second mode of vibration. N1 is the frequency of the second mode of vibration. So you can write here n1 is equal to V divided by lambda 1. Therefore n1 is equal to 1 by lambda 1, and what is V? V is equal to under root T by m. Okay, therefore this n1 is equal to 1 by, what is lambda 1 is equal to? Lambda 1 is equal to L. Lambda 1 is equal to L, and what is this? It is under root T by m. Now we can write this as 2 into 1 upon twice L under root T by m. This is n1. And what is this 1 upon twice L under root T by m? This is nothing but the fundamental frequency. Okay, so we can write here this n1 is equal to twice n. So this frequency is called as the first overtone. This is called as the first overtone, and it is the second multiple of the fundamental frequency. Therefore, it is called as the second harmonic. What is this? This is the first overtone, and this first overtone is equal to what? It is nothing but the second harmonic. Okay, so in the case of vibration of string in the second mode, this first overtone is equal to the frequency of the first overtone is equal to the frequency of the second harmonic. They both are equal. Now we are moving towards the third mode of vibration. Consider these are the repeat supports. Okay, and okay, now this is node, this is node, this is node, and this is also node. This is antinode, antinode, antinode. Suppose this is the length of the string, and now distance between two successive nodes is equal to lambda by 2. Between these two, lambda by 2 and this 2 lambda by 2, it is 3 lambda by 2. But as we denote the wavelength of the second mode as lambda 1, here we are going to denote as the lambda 2. So this is, so what we can write? We can write L is equal to 3 lambda 2 by 2. Therefore, this lambda 2 is equal to twice L divided by 3. Okay. So we know that what is the velocity? V is equal to n multiplied by lambda. So we can write here n2 into lambda 2 as we are in the third mode of vibration. So what is n2 is equal to? The second over to n2 is equal to v divided by lambda 2, which is equal to 1 by lambda 2 into under root t by m. And what is lambda 2? Lambda 2 is equal to this. So 1 by lambda 2 is equal to 3 divided by twice n under root t by m. Now we can write this as it is 3 into 1. Okay. So what is this? 3 into 1 upon twice n under t by n. It is nothing but the fundamental frequency. Okay. So this n2 is equal to 3n. So this n2 is the frequency of the third mode of vibration of the string, and it is called as the what? If it is the first overtone, then it is called as the second overtone. If it is called as second harmonic, then it is called as the third. So in this way, during the vibration of string, there is a formation of overtones and harmonics, and if we generalize the equation for the formation of, for the finding of frequency of the overtone and the harmonic, so we get a general relation here, and this general relation is N P is equal to P plus 1 into N. So this is the general relation where this P is the any integer, and this integer vary from 1. Therefore we can write P has a value from 1, 2, 3 up to infinity. Okay. So P is equal to 1, this N1 is equal to 1 plus 1, that is twice N. First overtone is equal to second harmonic, like that. So in this way, today we discuss about the vibration of string, and we also discuss about the different mode of vibration of the string and equations for the fundamental frequency, first overtone and second overtone, as well as the harmonics. So in this lecture, we discuss all about the vibration of string. In the next lecture, we are going to discuss the laws of the vibrating string. This is enough for today. Have a good day. Bye.